Okay, today's lesson is going to be pretty brief on odd or even symmetry and a whole bunch of little things about graphs. All right, so if you were to look at this graph, everybody just off to the side, make a little sketch of x squared. You're supposed to remember what x squared looks like. Did you remember it was a parabola that kind of looked like that? What would happen if I did that to it? Yes?
It'd go up 3 on the y-axis.
All right, it would go going, everything would go up 3. All right, everything would go down 2 on that one. If I look at this one, this is not down 2. What would that do? Right 2. How about that one? Left 3. All right, so good enough on all of that. And then they kind of get into, what if you took this and turned it into that? Well, this is just a normal quadratic, but this is a quadratic that's got a vertex. Do you remember that one problem where we were talking about vertex form? And everybody was confused about it? I get it. But do you get you can rewrite quadratics that way? That's still a quadratic. And the nice part is you can say, hey, it's moved 3 to the right. 3 to the right, and which way is the 4? And up 4. Okay. So today is not the day to try to teach you how to get stuff from here to there. We will talk more about it though. All right. I think you're going to know this, but I guess I don't know if you know this. This is the part where you should take notes. So I encourage you at this point to draw a little interval for increasing. And we're going to always just use parentheses for this. We don't have to worry about brackets anymore. It's just, it's increasing from here to there. Would you agree it's increasing all the way until it hits that moment right there? And at that moment, we could argue about whether it's still increasing at that exact second or if it just stopped increasing. You could make the argument, if you look from the left side, it's still increasing right to that moment. But then if you know the future that it's going to stop, then it's the beginning of when it stopped. So interesting argument, but we're not going to argue much about that. We're just going to say it's increasing from negative infinity until it hits what? Is it 1 or 3? Because this point right here is 1 comma 3. Does it increase until it hits the 1 or until it hits the 3? Well, it depends on your perspective on whether you're talking about how high it goes. Then it would be to the 3. If you're talking about, but the negative infinity gives you a clue. It's talking about x values. These are always about x values. Put that up in the upper left-hand corner. These are always x values. If you ever find yourself writing down the y value of a point, you're screwing it up. Yes, it goes to 3, but the question is, in this interval from here to there, like in this zone, you get how it's kind of like domain? In that zone, it's increasing. And so it's from negative infinity until 1. And then, does it immediately start decreasing? Oh, question? Yep.
I thought it starts at negative 6.
Well, I hear you, but we're going to assume that these graphs have little arrows in the end of them. But that's a very valid point. I'm just going to assume that they go forever. Okay, so negative infinity to 1. And decreasing, oh, wait a minute. It doesn't decrease right away. What's that next little stretch called? Tyler?
Constant.
And it's constant from where to where? 1 to, yeah, it's hard to tell. It looks like it's like 4.5 or something. But we'll say 1 to 5. I like it. And it decreases from 5 to infinity. All right. There. We've talked about increasing and decreasing. I'm going to make sure you really got that. So imagine for a second we had a graph that does this. And that spot there is at 1 comma 5. 2 comma 5. Tell me the interval over which it was increasing. Where was it increasing? And then where is it decreasing? Where is it increasing? Can you tell me the increasing interval, please? Negative infinity up until it hits 2. If anybody put 5, no, we don't use y values. Decreasing. Wolf.
-2 to infinity.
Negative 2?
Oh, not -2, sorry.
Okay.
Just 2.
2
I typed.
to infinity. It's okay.
I did the slash because I just typed negative.
All right, there we go. Any questions about increasing and decreasing? All right, that's pretty easy. And you kind of probably already knew that, except for the part that using the x values maybe. All right, how about this? Maximums and minimums. Before I even tell you anything, can you tell me what do you think that's going to be? That little dot that I put an arrow to? Does it feel like it's a maximum or a minimum? It's a maximum. Now you might be like, but there's a spot over here that's higher. Then that's the absolute maximum. There's a difference. It's kind of like this. Do you get in this room, if we had a competition, and we had an arm wrestling competition, and one person wins, do you get that they're the local maximum? They're the strongest in this room. Does that make them the absolute maximum? No. But in this room, there could be the winner of whoever's the strongest, okay? And it's like that. This is the highest spot locally, but in the whole graph, is it the highest spot? No, there was a higher spot over here. And that's called the absolute minimum, or sorry, maximum. And it's just a point. You just put what, comma, what, okay? And then absolute minimum, well, this looks like the lowest it was so far. But do you get, I can't really tell. This is a little vague. It might end up going down further than that spot. We don't know. Okay? And so you could make the argument that this problem, you can't really tell if that's the absolute maximum. But it's definitely a what? A local minimum. And I was saying maximum for a while there. I apologize. Minimum. It's definitely a local minimum, but it may not be the absolute minimum. We can't really tell because off the screen, maybe there'll be something lower than that. You're getting max is high, min is low. Yes?
So can you never know for sure if something is absolute or local because like the absolute maximum on that side, it could go down and then it could go up?
I get what you mean, but what we're going to ask you to do is if the graph ends up going up at the end of it, like that, for example, if we have an arrow going up, we are going to assume it will continue to go up, okay? But this one's weird because it's kind of going down, and so therefore it kind of isn't clear whether it's going to keep going down. Maybe it'll stop right there and turn, but that's a weird exception kind of a thing. On this one, on my W, would you please draw a W? It doesn't have to be perfect, exactly like mine, and label it with LM or L min for local min, and L max for local max. And if you have an absolute max, label it. And if you have an absolute min, label it. And by the way, I'm going to say this one goes a little lower on the left side than the other one does. Not much, but I think that one goes a little lower than the other one. Now this usually confuses people. They're like, okay, so this is the local minimum. Yeah. And this is the absolute minimum, because I just said it goes lower. And I know it's hard to tell, but let's just say that it's clearly lower and it's the absolute minimum. It's also a local minimum. It can be both. Do you get, if in our school, in our whole Minnetonka High School, the strongest kid happened to be sitting right there, okay? He is the strongest in the whole high school. Then wouldn't he be the local maximum and the absolute maximum for the high school? Yes. Now, if you really want to get into, like esoteric, like, okay, is he the strongest then in the whole world? How about the universe? Well, okay, then you're just trying to cause trouble. All right, so local min and absolute min, yeah, you're both. It's got to be the local min, in fact. If it's the absolute min, it has to be a local min. Locally around its neighborhood, it's got to be the lowest point in the neighborhood. if it's the lowest point of them all. You seem to have a question.
Yeah, are we gonna like label both of them?
Yeah, you would label it as both. You would say it's both of them. All right, and then the local maximum is here, L max, but there is no absolute max. This time I'm sure, because it's going up, and you might be like, well, where is it the maximum? Do you get there's a lot of functions that just keep going up? They don't ever stop and say, that's the highest point. No, it just keeps going. Then those have no absolute max, because it just keeps going. All right. So, imagine for a moment that we have to tell if something's even or odd or neither. All right. So that's going to be the pictures thing. Let's talk about that for a minute. Imagine for a moment I have this graph. Do you remember that that one has symmetry? Do you remember me talking about this? Do you have enough medium-term memory on this to remember? Do you think that's an even one or do you think that's an odd one? Well, how about this? Which kind of symmetry did it have? Yes? Y-axis symmetry. And y-axis symmetry was the even kind. That has even symmetry. Something like this, do you remember those? Does that have y-axis symmetry? No. Does that have x-axis symmetry? No. What kind does that have? Origin symmetry. And do you remember what that goes with? Origin is odd. They both have O's. Origin and odd. Okay. And this is the kind of problem where we did this for a while and then we kind of like set it aside. But do you remember the deal where I'd give you an equation? We've already been tested on this. And I would say, determine if this is even or odd. But we'd often say back then whether it had y-axis symmetry or x-axis symmetry or origin symmetry. And here's how these went again. You'd always stick something in. Who remembers? Yes?
To find even, to find the y-axis, you stick in negative x.
Negative x. In fact, for any kind of symmetry, you always start with a negative x. Everybody write this down, please. Write down the red equation, x to the third plus 2x. You stick in negative x, and you see what happens. Now, here's the two rules that are the key ones for now. Because there's only two we have to worry about now. We don't have three kinds of symmetry anymore. We're just talking about two things, even or odd. If you remember, if you've got a medium-term memory, what's the odd rule? And then what's the even rule? I'll give you a hint. They're like f of negative x has to equal what? Oh, sure. Just say it. Good job. So, was that even or odd, by the way? The one where it's f of negative x equals f of x. If it's just got one negative, then that's the even rule. F of negative x has to equal f of x. That's even. F of negative x equals negative x of f of x. That one was the odd one. And I like to go, it's got two negatives. That's odd. I don't know. It's dumb, but helps me remember it. All right. Those are not new. You knew them before. But it was 2-3 weeks ago. So let's finish it. We stick in negative x. We just did this on our most recent test. We had to stick weird things into the function, right? So we stick in negative x and we get negative x to the third plus 2 times negative x. Everybody write that out. You need one good example for yourself. And this hasn't changed. It's still f of negative x. But this side needs to be cleaned up. So that negative x to the third, does the negative still remain after you do it? Yes, there's a negative x to the third, and then there's a minus 2x. And now you have a moment. You say, okay, is this actually exactly the same as the original? No, it's not. And therefore, this is not even. If it had been exactly the same as f of x, we could have ended right there and said f of negative x was equal to f of x. And it was even, but it wasn't. And so here's what I can write. F of negative x is not equal to f of x. So it's not even. You'll want this later. Write this down. You've got to have one good example for yourself. Now we check the next thing, which is factor out a negative 1. If I factor a negative 1 out of this, negative 1 comes out to the front. And I get x to the third plus 2x. So what do you think we write now? I think you know, and I think you're just not saying it.
F of negative x equals negative.
Yup. Because that is f of x right there. That's f of x. And what rule is that? F of negative x was negative 1. See, negative 1, negative f of x. What rule is that? That's the odd rule. Therefore, this thing's odd. All right, that's all review. We did that before, but I know it's been 2-3 weeks. But at least it should be not like something you've never seen before. If so, you got to work on your memory. All right, I'm going to give you one more like that, and I want you to tell me whether it's even or odd. And the first thing you will do is you will stick in negative x, and then you'll simplify it down. And you're going to look and see if it turns into f of x. If it doesn't, you try sticking in that whole, like right here, this is key. You factor out a negative 1. Do you get if the thing is even, there's no point in trying to see if it's odd? Because it can't be both. Just to clarify, it's either odd or it's even. And if it's not either one, then it's just not odd and it's not even. That's it. There's that, and you could say that it's neither odd nor even, but there's no other category. It's either even or odd or it's not. Okay? Correct. All right. And it makes sense. We only have two kinds of numbers, even and odd. We only have two kinds of functions then. Even functions, odd functions. And then functions that aren't even or odd. Okay. Yes?
Oh, what about x-axis?
Yep, we don't have a, like we're talking there, we just have even functions or odd functions. Or ones that aren't even or odd. So if it's not even and it's not odd, if it's not an even function and it's not an odd function, then it's just not either one. And that does include some that have symmetry, but that doesn't make them even or odd. All right, so here's one. Tell me if this, it looks to me, because it's got a 4 and an x squared and a plus 2, it feels like this thing should be even symmetry, because it's a parabola and stuff. But that's not, just because I think it's even, doesn't prove it. Prove that this is an even function. Arshawn, what are you sticking in first? What are you going to put right there?
Why?
Give you a hint. Look back at this one.
Oh.
You put in negative x. All right, so we're going to put in negative x right here. All right, so everybody put in negative x. Max, can you tell me what to write next?
4 times negative x squared plus 2.
Nice. Now I got to simplify it. Charlotte, can you simplify this?
Negative 4x squared plus 2.
Yeah, the negative just disappears. Why does it just disappear? Because that negative times a negative will make it positive. And now you have to, if you think you've just figured out, oh, this thing's even, then what do you write? I'm going to write it in blue. F of negative x was, what's that even rule? Aman, you remember the even rule?
The even rule
F of negative x equals,
was f of x.
yes, because this is f of x, isn't it? That's the original function, so yay, we proved when we stuck in a negative that we got the original function back again. That's the even rule, therefore it's even. Any point in trying to prove it's odd then? No, it's even, can't be odd, yes?
On the test, you want us to say like it's not odd?
No, if you've proven it's even, I know that it's not odd. But, this is important, if you had just said it's not even, you can't just stop. Then you have to go on and see, is it odd? You know what I mean? But if you've proven it's even, you can stop. If you just figured out, oh, it wasn't f of x, so it's not even, then you have to factor out a -1 and see if it's odd. But no point in doing that on this one. Okay, cool. And that's it. So, on this one, it asks you to state the domain of the function. You should be able to do a domain. Identify any intercepts. Ooh, this reminds you about intercepts. The x-intercept is where, what? Y equals 0. And the y-intercept is where x equals 0. Okay, so here's my little y equals this. And if they want the x-intercept, you set y equal to 0. 0 equals 2 minus x. If you can't solve that, I'm scared. And if I want the y-intercept, I'll set x equal to 0. And this is y, right? Y equals 2 minus 0. Ooh, I got my y. I got my intercept already. The intercepts are super easy. And then, if you were going to graph this thing, would you agree that you're going to like it better if you wrote this? Negative x plus 2. Just because then you get your y-intercept where you're used to having your y-intercept. And your slope is right here. It's a 1. Technically, you could say it's a 1 over 1, so your rise over run, you know. All right. So, state the domain of the function, identify any intercepts, and test for symmetry. Well, if you just have to draw a picture of it and look at it, do you get this is going to be a straight line that goes through 2 and has a slope of -1, and I think you would have eventually figured out that was the line. Does that look like it has even symmetry? Does it look like it has origin, also known as odd symmetry? No, so it's neither one. That's a neither. And you can just look at them, unless they say analytically test. That thing where you actually grind it out with the negative, that's analytically testing it. This is just looking at a picture, and it's good enough. You don't have to show me an algebra test. That's called proving. This is testing. Testing means like, once you've got it graphed and you look at it and you go, you could just say look at it and determine if it's got x-axis or y-axis symmetry. So they did not ask for a proof. As soon as they ask for a proof, you have to bust these out. F of negative x equals whatever. Those are the proofs. Okay, cool. Should you do some of these? Yeah, what if you're like, I don't remember how to graph this. XY chart is your best friend in graphing. You get to go any numbers you want for x, so I'm going to choose 6. Strategically picked 6 so that I'd have the square root of 4, which is 2. And some people still have this problem. They think that the square root of 4 is 2 things. And I remember I showed you why. Somebody taught you that wrong. And it was in good intentions and everything. We were trying to skip a step for you when they were solving these. And they thought, well, we'll just make it easy for them and say x equals plus and minus 4. But then everybody thinks square roots have 2 answers, but they don't. Its absolute value of x equals positive 4. And then the absolute value causes you to have 2 answers. My point, I still had multiple people on this last test that lost the point because they were doing a square root and they gave me 2 answers for it. Square roots only have 1 answer. It's only when you're square rooting a variable that you get an absolute value that gives you 2 answers. Okay, so if you're stuck and you're like, I don't know how to graph that, do you know how to make an XY chart? Question?
Can I go to that?
Sure, no problem. So if I'm gonna stick in x on this function now, if I'm gonna stick in x equals 1, I pretty quickly can go 1 over 1 squared plus 1, which is 1 over 2, which is 1/2. X is 1, y is 1/2. I can find a dot for that. And I know you don't know what this looks like. Once you get a few dots, you'll figure out what it looks like. It might take you 5 or 6 dots, but eventually if all the dots are lining up like this, you'll be like, oh, it's one of those. All right. Let's move on. More homework. I feel like this would be a good reminder, but I don't feel like we need to do a really hard one. So let's skip this one. I would do 17. Now on this. This is that ultimate page. Yes, you need to know all of these. I'd recommend doing all of them. They won't take long. What's the range of f? You know what range is, right? Lowest to the highest. Okay, this is a good review right there. This, along with that little thing where we stick negatives into the function, is the meat of today. You can just remember how to do these things. So definitely work on that during the rest of this hour. And I'm going to hand the test back in a minute, and I'll go over the most important problems off that test. And that's all I got for you for today.